Good morning, everyone. So now we are seeing about block diagram reduction technique. Last class we have seen few problems on it. Today also we shall continue the problems in block diagram reduction technique. So here this problem number 6, a block diagram is given. Here there are some blocks in forward path G1, G2, G3, G4 and H1 and H2 are provided in the feedback path. So here we need to reduce the block diagram and find the closed loop transfer function of the system. So first we need to check whether there is any series blocks or parallel blocks or any negative feedback block. If we see so there is no such block, then what can we do? We can adjust a summing point or move a summing point or move a branch point and obtain a series or parallel or a negative feedback loop and all. Okay. So likewise, if you see here, if we move this branch point before the block G2, we may have two blocks G2 and G3 in series, and after that we can have a parallel block also. So what we have to do means, first we need to move this branch point before the block G2. So as per the rule, while moving a branch point before the block, what is the block should be added in the branch point path? We need to add that block. That is, we need to put the same block in the branch point path. Okay. Thus, after moving this branch point before the block G2, we obtain here. See here, we have included the block G2 in the branch point path. So here we have moved this branch point before the block G2. So we have included the block G2 in the branch point path. Okay, the rest of the thing same. So here to avoid that interconnection, we are having this jumper like that. Okay. So next if you see here means we are having series block. G2 and G3 are in series. After combining this G2 and G3, we will have another parallel block. That is G4 and G2, G3 will be fed to the summing point with a positive sign. This makes a parallel block. So we can convert the series block as well as a parallel block in a single step also. So while converting, here I have obtained, first I have multiplied the series block G2 and G3. So G2, G3 plus the parallel block G4. So G2, G3 plus G4 is obtained the step 3. Next, we shall see whether there is any series block or parallel block or negative feedback or there is no such thing. But here if you see, there is a possibility of negative feedback, but here we are having a branch point. So we can't. See here we are having a negative feedback, but here we are having a summing point. So we can't move this branch point before the summing point. So what we are going to do means we are going to move this summing point before the block G1. Okay. So as per the rule, while moving moving a summing point before the block, what should be done? 1 by that block should be included in the upward or downward input given to that summing point. So here we are going to include the block G1. That is 1 by that block G1 will be included. So after moving the summing point before the block G1, we have obtained the block diagram shown in the step 4. See here we have included 1 by G1 in the downward input given to this summing point with the negative terminal. Okay. So if you see here, we are having two branch points connected here. So for easiness, we can split this branch point. As well as what we can do if you see, we thought of making it as a negative feedback loop. So to make it as a negative feedback loop, what we have to do? we can interchange the summing point. So, simply by interchanging the summing point. So, interchanging the summing point doesn't require including a block like that and all. Okay, for interchanging it, we have to give the corresponding input to that summing point correctly. So, while doing so, here in the step number 5, we have interchanged the block and obtained this block diagram. See here, the first block has input H1, G2 in downward direction. See here, the third block is having the input G1, H2. See here, the third block is having the input 1 by G1. See here, after interchanging, the 1 by G1 is given to the second block, second summing point with the negative sign. Okay, like this, we have interchanged the summing point. After interchanging the summing point, if you see here, we are having a feedback loop. It is a negative feedback loop. Then we can reduce this negative feedback loop. See here how we are reducing this negative feedback loop. As per the rule, by the formula for negative feedback loop is G by 1 plus GH. So instead of G, here we are having G1 and instead of H, we are having H1 G2. So if you substitute in that equation, we will be obtaining this block. So it is given here. Okay. And then if you see here means this step number 6, we have replaced. That is, we have reduced the negative feedback loop. And then if you see, here we are having 2 blocks in series. So we can simply multiply the 2 blocks and make it as a single block. Like this, we have obtained in step number 7. Okay. And the next here, if you see in the step number 7, here we are having a feedback loop. It is a negative feedback loop. This negative feedback loop, instead of G, we are having this block and instead of H, we are having H2 by G1. So, as per the formula, there is G by 1 plus GH. The values are substituted. Okay. So, after substituting the value, we can simplify this equation as given here. That is, first of all, we can cancel this G1 here and this G1 here in the numerator. We can cancel the denominator. If you see in the denominator, we are having the second part, we are having G1 in the numerator and G1 in the denominator. We can cancel it and then we can multiply this G2 inside G2, G3 and G4 into H2. After that, if you take LCM means we will be obtaining this equation. After taking LCM to the denominator part, we will be having this equation. Okay. So, see here in the numerator and denominator, we are having 1 plus G1, G2, H4, H1 and 1 plus G1, G2, H1 in common. So, we shall cancel it. Okay. So, the equation is formed like this. So, we can substitute this value instead of this negative feedback loop. Okay. So, by substituting, we obtain this block diagram as shown in the step number 8. See here, in this step number 8, we are having a negative feedback loop with a unity feedback. Okay. Here, this negative feedback loop, there is no block at all. So, here the feedback path gain is considered as 1. So, in this unity feedback loop, instead of H, we are having 1, thus substituting the values in the equation obtained for negative feedback loop, that is G by 1 plus GH, we can have equation like this, and then by simplifying this equation, that is I have taken LCM to the denominator and see here I have taken LCM to the denominator and I have cancelled the terms common to the numerator and denominator and thus obtain the transfer function of the system. Okay, clear? So, once again I shall explain the steps alone. This problem number 6. See, first we are moving a branch point before the block. So for moving the branch point before the block, we need to include that block in the branch point path. After that, here we are having some blocks in series. We can combine those blocks. And also here we are having parallel block. So we can combining those parallel blocks and obtain this step number 3. Next, if you see, to obtain the negative feedback, we can interchange the summing point. So before interchanging the summing point, you need to bring this third summing point before G1. So the block diagram will be like this. After that only we can interchange the summing point. So after interchanging, the block diagram looks like this. Then here we have simplified the series block as well as the negative feedback loop. Thus we obtain this block diagram. And here we are having another series blocks. We are just multiplying those series blocks and we are obtaining this block diagram. Here we are having a negative feedback loop again. So simplifying it, we will be obtaining this block diagram. So in step number 8, we are having a unity feedback loop. So solving this unity feedback loop, we shall obtain the transfer function. Okay. Next we shall see another one problem in a block diagram reduction technique to find the closed loop transfer function. See here this problem. We are having some blocks in forward direction G1, G2, G3. As well as this G4 is also given in forward direction and H1 and H2 are given in feedback path. See here, we need to search whether there is any series block or parallel block. Here there is no such series block or parallel block or any feedback loop also. So what can we do? We can split this summing point. So before splitting the summing point, you see here, there is H1 is fed to the summing point as well as to the first summing point and second summing point. H1 is fed. So this H1 goes to a transmission point and it is fed to both the summing point. So this point is known as transmission point. This transmission point is transmitting this value of H1 to the first summing point and second summing point. So if we are having this, we can split this transmitting point also. Okay. So first we shall split the summing point. So for splitting the summing point, we can make it as a feedback path. So keeping that in mind, we can split plus minus, there is H2 minus the first summing point and H1 minus H1 the second summing point. So like that we can split. Then see here, this block diagram, this H1 is fed to both summing point. So I have separated H1. Separately here H1 is written to minus of the summing point, that is the third summing point. Also this H1 is again written separately to the first summing point with the plus sign. So here we see in this block diagram, H1 only is given to the first and second summing point. So for easiness, this H1 is split to first summing point separately as well as to second summing point separately. So after doing this, we see we are having a negative feedback path. So this negative feedback path can be eliminated by the formula and thus we obtain this single block instead of that negative feedback loop. And then we see how can we reduce this block diagram. If we move this branch point after this block G3, then there will be a possibility of having a negative feedback loop here. So keeping that in mind, we shall move this branch point after the block G3. So as per the rule, for moving the branch point after the block, we need to include 1 by that block in the branch point block. See here, after moving this branch point after the block G3, we have obtained 1 by G3 in the branch point path. Okay. After that, if you see, here we are having these two blocks in series. That is G2 by 1 plus G2 H1 and G3 are connected in series. So, these series blocks can simply be multiplied. And after that, if you see, here we are having a negative feedback loop also. So, here we have substituted the value of G and H in this negative feedback loop elimination formula. That is G by 1 plus GH. See here, first of all, we are combining the series block. This is done internally. This is done implicitly. Okay. After that only, we have framed a block for negative feedback loop. So, this block is reduced like this. First of all, we have to take LCM of the denominator. See here, I have taken LCM of the denominator term and I have cancelled the common term 1 plus G2 H1 and 1 plus G2 H1 common to both numerator and denominator, and thus obtained this equation. This equation only is substituted in this negative feedback loop elimination block. Clear? After that, we see here again we are having a two block in series. This G1 and G2 G3 by 1 plus G2 H1 plus G2 G3 H2 are available in series. So combining those series block, that is simply multiplying. G1 will be multiplied to this, and after that if you see here we are having a positive feedback loop. So what is the reduction formula for positive feedback loop? G by 1 minus GH. So substituting the value of G and H, we will be having like this. Okay, see here instead of H, this step number 5, we are having H1 by G3. So this substituted here. This H1 by G3 is substituted, and the solving part is given in this slide number 12. If you see here first the denominator, if you see the second term, this G3 is common in the numerator and denominator. So this G3 is cancelled. Okay. After that we are taking LCM of the denominator. It will be like this. So again we are having a common term, the numerator and denominator cancelling, we will be obtaining this equation. So this equation is substituted in this block given in step number 6. Okay. So here in the step number 6, if you see, here once again you are having a parallel block. Okay. Don't consider it as a feedback loop. It is a parallel block. See here, this arrow is from left to right, that is in forward direction in G4, and in forward direction only this G4 is fed to the summing point. So it is not the feedback loop, it is a forward path gain. G4 is in the forward direction. So these two blocks are in parallel. So how we shall simplify the parallel blocks? By simply adding those two blocks and making it as a simple block. So I have simply added those two blocks and I have obtained a single mathematical equation, just nothing but our transfer function. Okay. Thus we have obtained our transfer function. Clear? So once again I shall repeat the steps which we are seeing in this problem. So first step, we are splitting the summing point into two, and then here we are having a branch point. Alright, here we are having a transmission point because this H1 is transmitted to first summing point as well as to second summing point. Okay. So we need to split this branch point. So we are giving this H1 separately to this second summing point as well as to the first summing point. This is shown in the step number 2. And then we are reducing the obtained negative feedback loop. After that, we are moving this branch point after the block G3. For moving the branch point after the block, we need to include 1 by that block in the branch point path. So it is included in the step number 4. See here in the step number 4, we are having a negative feedback loop, and also we are having a series combination in the two sides. So we can simplify those, and we have obtained this block as shown in the step number 5. And the step number 5, you see G1 and this block are in series. So we can simply multiply those two blocks. After that, if you see here, we are having a positive feedback loop. So that positive feedback loop is eliminated, and thus we are having block like this shown in the step number 6. And then again we are having a parallel blocks. So we are combining the parallel blocks by simply adding those two blocks, and we obtained a single equation which is nothing but our transfer function. Okay. Next, we shall see another one problem. So see here in this problem 8, we are having blocks G1, G2, G3, G4 in forward direction, and in the feedback path we are having H1, H2, H3 and H4. First we will search for any series block or parallel block or feedback loop. No such thing is present. Okay. Then we have to find a way for making those by moving a branch point or splitting the summing point or moving the summing point. Okay. Here we are having a combined branch point. So first of all, we can split this combined branch point. See here, in the step 1, if you see, this C of S is a output. This output is fed to the second summing point with a negative sign, as well as the C of S is fed to G1, and the C of S is fed to H1 and H2, and then it is fed to this last summing point with the negative sign. Okay. So for easiness, we can split these two branch point. So here see, we have splitted the branch point that the C of S is directly fed to the second summing point with a negative sign. So C of S is directly fed to the second summing point with the negative sign. And we have seen in the previous step, the C of S is also fed with the H1 and H2 to the last summing point with the negative sign. See here, this is obtained here. The C of S is fed to H1 and H2 to the last summing point with a negative sign. Okay. So like this, we have obtained the block diagram here. Then here we can see we are having series blocks. So combining this H1 and H2 in series, and then if you see here we are having a negative feedback loop. So we can simplify this negative feedback loop as per the formula G by 1 plus GH. So instead of G we are having G4, H we are having H1 and H2. Thus we obtain this single block. Next, the rest of the thing same as the step number 2. Okay. Next, here we can see whether there is any possibility of series block or whether there is any possibility of series block or parallel block like that. See here, we are having this series block, but what I am going to do means, if I move this branch point after this block, and after that if I move this branch point after this block, I will be able to solve this parallel positive feedback loop. Okay, that is, if I move this branch point after the block G3, and after that if I am moving this branch point after this last block, I will be able to have a positive feedback loop. So keeping that in mind, what I am doing, first I have moved this branch point after the block G3. So for moving the branch point after the block, we need to include 1 by that block in the branch point path. See here, 1 by G3 is included in the branch point path. Here we can also combine this G2 and G3, but here we are having a branch point. So we can't combine G2 and G3. But here this G3 and G4 by 1 plus G4H2 doesn't have any branch point or summing point in between. So, if you need to combine these two blocks, you can combine these two blocks. After that, you can move this branch point after the combined series block also. You can do in any manner. It is not mandatory to follow the same procedure for solving the problem and all. You can use any procedure. It is your wish, but the answer, final answer will be same. So see here, here I have moved this branch point after this block. After that, what we can do? Again, I am going to move this branch point after the last block. So I have to include that last block in the branch point. That is 1 by that block. That is a reciprocal of that block is included in the branch point part. See, it is shown in the step number 5. Clear? So if we see here, we are having series blocks here and here we are having series block. So we can reduce this series block by simply multiplying those two blocks and all. After that, we will be having a block diagram like this. See here, we are having a positive feedback loop. So we can apply the reduction formula for positive feedback loop. What is the reduction formula? G by 1 minus GH. So while doing so, here we will be obtaining this equation. So the simplification, detailed simplification step is provided below. Okay, you can refer it. And also if you see here, we are having two summing point here. These two summing point is exchanged means here we will be having an inner loop and then an outer loop. So keeping that in mind, I am exchanging the two summing points with the same input given to that summing point. Okay, along with that input, I am exchanging the summing point and I obtain the block diagram as shown in this step number 7. See, after interchanging the summing point and after eliminating the positive feedback, we will be having block diagram like this. See here, we are having G1 and G2, G3, G4 in series. So simply multiply those two blocks and write in a single block and then you can find a negative feedback loop. So this negative feedback loop is solved by using the rule formula, that is G by 1 plus GH. So we are substituting the values and we will be obtaining this value. So the detailed simplification of this obtained reduced negative feedback loop block is given this slide number 18 for your reference. See here, first we have to cancel this G3, G4 is available in the denominator, the second half. So we are cancelling this G3, G4 is common to both the numerator and denominator and then we can multiply this denominator to this 1. That is by taking the LCM. Can take the LCM. After that, you see in the numerator and denominator, we are having a common term. So that common term is cancelled and we obtain this equation. So this equation only is given here. Okay. So instead of this negative feedback loop, we have to substitute this equation. Okay. So while doing so, I will be obtaining the block diagram as shown in this step number 8. So see here, after this reduction, we are having another negative feedback, but in the feedback path we are having the feedback path gain as 1. So it is unity feedback loop. So see here, the same reduction formula for solving this negative feedback loop, assuming h is equal to 1, here it is substituted and the solving procedure is given in detail here. That is, first we have to take the LCM of the denominator, then we are cancelling the two terms common to the numerator and denominator and thus we obtain the transfer function here. Okay. So I shall repeat the procedure for this problem once again. So in the first step, we are rearranging the branch point for our easiness. So, the C of S is directly fed to the second summing point as well as the C of S through H1 and H2 is fed to this last summing point with the negative sign. And in the next step, we move the branch point after the block for converting it as a positive feedback loop. After that, we need to move the same branch point after the last block also. And thus, moving will be obtaining the positive feedback. Before obtaining the positive feedback, here we will be having two blocks in cascade and all. So, just multiplying the series blocks and then apply positive feedback, and in the feedback path also we'll be having a series combination. So combine those series combination also, and after that solving that positive feedback we'll be having equation like this. Okay, then we'll be having a negative feedback loop. Then that negative feedback loop also will be solved with that combining G1 and this block. Okay. Then after solving this negative feedback loop, at last we'll be having a unity feedback loop. So finally that unity feedback loop is also solved, and thus we have obtained a transfer function. Okay. So clear? So in today's class we have seen few problems on block diagram reduction technique. So using that technique we found the transfer function. Okay, thank you.